Hi everyone, my name is Chris Seeley. Welcome to this screencast. I'm a developer programs engineer on the DoubleClick for Publishers developer relations team, and today I'm going to be talking about change history, and specifically how to use a new feature in DFP, change history, to set up notifications. So to start with, we found that a lot of our developers are doing local syncs and essentially data dumps of information in the API. And one of the things that we've gotten a lot of requests for is being able to access change history, so you know exactly what entities change. So I'm happy to announce that starting in v2017-02, we've added a new table to the Publisher Query Language Service for change history. If you're not familiar with the Publisher Query Language Service, it's a read-only service, and you have tables, essentially, that you can read from in a SQL-like syntax that we call the Publisher Query Language. So you may already be using it for something like geo-targeting to get information about geo-targeting IDs. And now there is a new table called change history, change_history, and it's got pretty much everything you'd expect from a change history table. So it has a change date time, it has an entity ID, and this is the ID of a line item or an order that you can see that you can get from the dedicated services like the line item service, or you can see in the URL and the UI. And then it has the entity type. This is an enumeration indicating what type of entity was changed. It has the operation, whether it was a create or an update. And finally, it has the ID of the user that made the change. It's just the ID. If you want additional information like their email address or their name, you can use the user service to get other additional information based on that user ID. There's also an ID column. It's not a numeric ID, it's alphanumeric, as you can see, and I'll show you more about how you can use that in just a second. So those are the columns that are available in the change history table, but how do we actually use it? There's a couple of restrictions on the table, and I'm going to walk you through building a valid query. The first thing to note is that the only supported ordering is by change date time descending, meaning that the newest changes are at the top. And this is consistent with what you see in the UI. When you go into the admin tab and change history, you'll note that the newest changes are at the top of that table there. The second thing is we don't support the keyword offset. So this is the pequel keyword that you would use in the other services when you're paging. You'll get one page and then you'll offset and get the next page of results. That keyword's not supported in the change history table. And finally, every query will require a DateTime window, meaning you need both a start and end time that you're looking at for changes. So what does an actual valid query look like? It's going to be our standard select from where. So the select, we're going to select all of those columns that I already showed you, ID, change date time, etc. From change history with an underscore, limit 500. So you should always include a limit in your queries no matter what service or table you're reading from. It's not going to work if you try and dump out all of the change history in a single request. And you'll actually get a syntax error from the change history table if you don't include a limit. So we'll limit by 500 entities. And then we'll add our where clause. So this is that date window that I was talking about. We're going to provide both an upper bound and a lower bound for when we want to retrieve changes from. There's also the order by. If you don't include an order by clause, since there's only one order by that we support, it'll automatically be imposed. But for clarity, they'll just add an order by, change date time descending. Again, newest changes at the top. But wait a second, this is only 500 changes. What if there are more than 500 changes in that window that we supplied? And that's where the ID column comes in. So instead of paging with that offset keyword, which I already mentioned is not supported, we're going to use the ID as a pagination or continuation token. So when we need to go to our next page, instead of doing an offset, we're going to say end ID less than the last ID in the first result set. So you're going to look at the result set, grab the last row, and grab the ID from that row and filter on that. So think of the ID as a continuation token or a pagination token rather than a unique identifier, because that's how we're going to utilize it. So to take a look at what I'm talking about, here's the look at that ID again, and say we wanted to continue on, say the QQ was the last row in our result set. In order to continue on, we're going to do where ID less than QQ2JT, etc. And then the first row in our next result set will be the UMP row. So we're going to get changes earlier than the QQ. So this raises the question, but why? Why do we have all of these restrictions on the change history table? So let's pull up those restrictions again and take a look at them one by one. So only order by change date time descending. I mentioned this earlier, but that's because that's what the UI supports. We wanted to get this feature out so that you could start using it in the API. So we have the same limitation that the UI does, and we just weren't able to support at this time anything other than change date time descending. So that's in line with the UI. That makes sense. But what about the offset support? How come we don't have the standard offset keyword and page that way? How come we have to use the ID as a continuation token? What's wrong with offset, in other words? Well, let's take a look at an example of what would happen if we used offset. So the offset meaning is the offset to sort of identify a pointer to a row. So say we did offset 2 and we point to row 1000 here. We expect that we're going to continue on at this row. But what happens if after we make our first request, someone changes an entity in our network? Because we have change date time descending, the newest entity goes to the top of the list. So when we're offsetting by 2, we're no longer pointing to that row 1000. It got bumped when the new entity came in at the top of the result set. So a simplistic offset doesn't work if there's an entity added during your paging. On the other end, if you use a pagination token where ID is less than 1001, so you'll see here that we're pointing to the row prior to 1001. If a new entity gets added to the result set because someone changed it in our network, our pointer is still going to the same exact place. So we're still continuing on from the same location, even though changes have happened between our API requests. So the result set could change between your requests is the reason that we need to utilize a pagination token. So no offset support, we'll check that one off, and we'll use a continuation token instead. Makes sense because of that order by the newest results going at the top. So finally, why do we require a DateTime window? So here's an example query that might look familiar if you're doing a local sync with any other service. You sort of record your last sync time, and then the next time you go and make a request, you sort of pull that out of your own database and filter on anything that has changed since that time. So I only care about things that are newer than that time. But this isn't supported. You'll get a syntax error in change history if you just do this. So why are we requiring a time window? A lot of you may already know that the DFP API has its own DateTime representation, a DateTime object. So on the left, I have an example code that instantiates a new DateTime object. On the right, I have documentation from Cloud Spanner. If you haven't heard of it, it's a database technology that you can use through Google Cloud, but it's also the same database technology that backs a lot of Google products, including DFP. So because it's a database technology, I'm going to do a select, and I'm going to select the current timestamp, and you'll see that the left and the right are roughly the same date time, right? The same representation. They're both on May 16th, 2016, and they have the same time and time zone. But you'll also notice that the database has a fractional second representation, whereas our API doesn't. So the database has a much more granular view of time than is exposed in the API's DateTime object. Why is this important? Why am I bringing that up? It's because you might get weird behavior if you didn't have a time window. So let's take a look at this. If you just did change date time greater than this time here with 21 seconds, you might get this result back. And if you'll look, you'll say, wait a second, I said greater than 21 seconds. I didn't say greater than or equal to 21 seconds. Well, under the hood, it actually is greater than 21 seconds. It's actually almost 21 and a half seconds. So when you include a time window, both an upper bound and a lower bound, you effectively truncate the time to whole seconds, because that's the granularity that is exposed in the API. And that way you ensure that all of your results are within the expected window. Okay, so we've checked all of our boxes. We know that the final one is because of a time granularity difference between the DFP DateTime object and the actual timestamp of the change. If you feel like you're going to have a hard time remembering all of this, don't worry. We have example code available on all of our client libraries that shows you how to make a valid change request and sort of follows the example of getting all of the changes from the last day and pages through, handles everything for you, so you can get started with example code in every one of our languages. This link goes to Java, but you can go to any of our other libraries on GitHub and get the same example. So now that we know how to build a valid query and utilize the change history table, let's talk about something you can actually do with it, something interesting you can leverage it for, and that is notifications. So one example of a notification is if someone is in DFP making changes to line items in the network, if I've already invested a lot of time and making a perfect line item, and I'm doing something else and I'm not in DFP, I want to know about it when someone makes a change to my line item, right? I want to get a desktop notification that says, hey, someone changed your line item that you worked hard on. You might want to go check it out. So to achieve this, I built an example application using the DFP API and a couple of other technologies. If you're not aware, both our Java and Python client libraries will run on App Engine. So I utilized App Engine to host my program. And I also leveraged a Google Cloud technology called Cloud PubSub. So if you're familiar with Kafka or the publisher-subscriber programming concept, it's essentially an abstraction for messaging. So you don't have to worry about the details of delivering messaging between multiple applications. You just publish a message and all of the subscribers get the notification. And one of the subscribers that I created was a Chrome extension that will show that notification. So as I mentioned, if you wanted to take a look at the PubSub and you're not familiar with it, there's a publisher, and the publisher will create a message, and then the subscriber subscribes to receive those messages. And you'll see that blue area in the middle is Cloud PubSub, and that's what handles all of the details of how to deliver those messages. So you don't have to worry about it. As a subscriber, you just receive the message and then acknowledge that you received it back to Cloud PubSub so it knows that the message has been delivered. And the other advantage is you can have multiple subscribers. So your publisher can publish one message and have multiple subscribers receive it. So when my Chrome extension receives a message, it will take that message and turn it into a desktop notification. So that's the long and short of how it works. And now I will show it off in a quick demo. So here's my perfect line item that I don't want anyone to update, but someone does anyway. So I'll go down and save this line item. So it's saved. And I'll switch over to the admin tab in the change history. And you'll see if I refresh this page here, it'll have a new entry in the change history table. And the information in this table is available programmatically through the API, so you can see the newest change did show up. And what's going on in the background, and there's my change notification. So I'll click it and open it. But what's going on in the background is that App Engine project is running essentially a cron job to pull new changes from the change history table. And then when it receives one, it'll use Cloud Pub Sub to deliver the messages to the subscribers. And you'll see here I have a Chrome extension added that is checking on essentially another cron job for new messages from PubSub. And when it gets them, it displays that notification that you just saw. So that is my quick demo. Easy to accomplish. And just one final note, although I only have the one Chrome extension, if you're using Cloud PubSub, you can have multiple subscribers, like I mentioned. So you could have multiple people have Chrome extensions installed and they would all get a message. Or you could kick off other processes that you might have. So if you have a Python application that's sort of doing an auditing log that you're interested in changes, or if you have a reporting pipeline that you want to kick off based on changes in your DFP network, you can have one application that connects to the DFP API and sort of build your own push notification framework for any other jobs or applications that you might develop. So the benefit there is having multiple subscribers in a PubSub environment will reduce the total volume of API requests and help keep you under quota. So all of those applications don't have to check change history. You can have one application that is sort of doing all the checking and notifying your other suite of applications that care about changes. So just some final words of wisdom there, and thanks a lot for listening.